This video is the first lab in the Hydrological Applications module of the workshops on conservation applications of LiDAR. The first step will be to acquire this information for the exercise, which is stored in a PDF which could be found at the web page of MinGeo State Sea House Elevation LiDAR under the Workshop Training Materials. It's also important that for this exercise that you have a digital elevation model, a LiDAR digital elevation model for your area of interest, and access to aerial imagery for that same area. If you don't have imagery for that area, I will show you how you can access the MinGeo aerial imagery to compare with your DEM. The purpose of this exercise is to learn the basics of DEM display as in support of hydrological applications. We'll talk about environmental settings that are necessary to establish for your raster processing and demonstrate several different display options for the DEM to better identify hydrographic features and perform delineation. The first thing you need to do is to start ArcMap. Then you load the DEM from your area of interest. Next, we need to work with Spatial Analyst, so we want to make sure that you've got Spatial Analyst turned on. So in Customize Extensions, we make sure that we have Spatial Analyst and 3D Analyst turned on. Other ones don't matter for this particular operation. It's Spatial and 3D that you'd be using. The next step is to talk about environmental settings, and under the Geoprocessing tab, which is new in 10.1, or 10.0 as well as 10.1, there's an important environment tab as well as a results tab. And the environment tab is what we'll talk about first. The results we'll talk about a little later so that you could see what's happening, because as these LiDAR jobs are running, that sometimes you need to interrupt them, or sometimes you need to review your progress or find out where you put something by mistake. But the best approach is to set the environment at the beginning. Click on the Environment tab. Now there's several things we want to talk about. Workspace, where your work activity, and make sure you've got enough room there. Output coordinates and the extent are some of the key values. Now there's several things about the environment settings. We're setting the environment settings at the application level for the entire work session that we're performing in ArcMap. It's very possible within Spatial Analyst to set the environment for a particular tool, for just that tool, or if you've established a model, to set it at that model level or a specific step within that model. So the environment settings can be set at several different levels, and sometimes it's very efficient to set the whole environment at the application level, though occasionally you need to customize it at a lower level. Now we're going to set the workspace, so we left click on it and we want to set the workspace, and I'm setting the workspace to a particular location I've established. Yours will be different. You just have to pick where it is, but you want to remember and have some sort of structure. In this case, I'm saying it's going to display data. Next, I have to set my Scratch workspace, and how you set it is by clicking the tab over here and select that particular folder. Now, as I said, if you goof and you forget this, that you could go up to in geoprocessing, we could go to the results and actually see for that particular session where you ran something and where it went. So you're able to see your footprints with that result if you goof and you forget to set this environment setting at the beginning. We've set the workspace. Now we're going to set the output coordinate system, and we want the output coordinate system, and this is important so everything matches because they all have to line up. The coordinate systems have to line up. We're going to say same as the, not same as input, same as our digital elevation model. Then we're going to roll down into the environment settings to the processing extent. Okay, that's where things are being processed on the Earth, and we'll want to make sure we set that to be the same as our DEM, and it automatically fills in the outline coordinates of, and our snap to raster is also our DEM. So any layers that we process will snap to the outline as well as to the grid structure and the coordinate system of this particular DEM. So everything will line up. Okay. Oh, I forgot one particular one, so we'll do it again. Environment settings. I didn't do the cell size. I've set that, but I didn't show you. So under raster analysis, so we did workspace, output, processing extent, and the raster analysis. Now we're going to do the raster analysis, and our cell size will be the same size as the DEM layer. And we say OK. Now for this exercise, we're going to be calculating the TPI, and the TPI requires some special software to be installed. And I've installed that, and I'll provide a video for the installation of that. But I'm going to show you after you've got it installed, you download it from the site that I'll give you on a separate of a little video exercise, and it's written up also in the notes. That you will select here is the land facet analysis. So I've got that turned on, right? And I've got that displaying on my toolbar. So I have that as available for me to use. Now, after you've got things set up for these sorts of the DEM visualization for hydrology, it's probably a good idea if you save this. So all the environment settings and sort of the base information is set. So I'm going to do save as and save this as a, and I'm going to call this in my, I'm going to in a particular location where I'm saving my project, call it DEM display project, just so I've got that, so I don't have to set those environment settings again. Okay, now the next thing we're going to do is to do a hillshade, and there's several different places we could work on a hillshade that we've talked about before. Now we're going to create, for this exercise, we're going to actually create a hillshade layer. So I'm going to use the Spatial Analyst Tools Surface Hillshade, and I've selected the DEM, our DEM as my input. I've given the output the name that it's selected, suggested in the instructions. The important thing is that I gave it something I can remember what the heck it is. I said hillshade. Then I have to, as we talked about in the lecture, talk about where the sun is located for my display of the shadows, and then how high the sun is from the horizon. In this case, I'm using the default at 45 degrees. Then I often see this value sometimes in the Z factor. And you want to remember this, when you see 0.3048 in the Z factor, what's happening here is that the DEM has units are in meters. And somebody is converting this process to feet. So we're dividing the meter, the 1 meter, by 0.3048. Now, in our case, we want to keep the units the same, so we'll put this as 1 meter. But you want to remember that the Z factor is a way that you could divide or multiply the Z factor, the base units of your DEM. I'm going to say OK. And when that's completed, I've got the hillshade available to me. Now I'm going to go up to geoprocessing and show you the results here. If I go to geoprocessing results, now I can see what I just did. If I did geoprocessing results, my current session. I could see that hillshade was calculated, what my output was. I could see my input. I could see my parameters, the environment settings that I had set for that particular session. And in this case, they defaulted from my overall project. But you get an idea of how you could see what you did in case you're confused. Now we're going to display the hillshade information, and we want to go to properties of that hillshade, right-click properties, and we're going to do things in the display tab and the symbology tab. And in the display tab, we're going to display using, instead of the nearest neighbor, which is the default, we're going to use bilinear, which is really best for continuous data. The nearest neighbor is for discrete data. Then we're selecting the symbology tab, and we're going to use stretched, and we're going to use the grayscale, and we're going to use standard deviations, and we're going to use, instead of the default of 2.5, we're going to use 2, and then a little further down, pull down, we're going to use from the display extent. Okay, we apply OK, and you get an idea of how this looks. You get an idea of the shadows that the hillshade is representing, and how where we displayed the sun, which was up here at 45 degrees. Now we're going to move the hillshade below, and if you can't move it below, make sure this tab is set, not the file path, but the tab over here. Then pull the hillshade below the DEM. Then we're going to go back to the DEM, right-click Property, and in the Display tab, we're going to set this as bilinear also, and we're going to set the transparency at 55. Apply. Symbology. Now we're going to set our color ramp, and I'm going to use the traditional Esri DEM color ramp, which is the traditional one that's used is, let's see, move up to the bottom. You can see that it starts at the light blue and goes all the way to white, so there's many different colors that are shown for the continuous data. And again, I'm doing standard deviations, but I'm doing 2, and I'm doing the display extent, current display extent, apply, OK, and it should look like this. So the DEM is on top, that's transparent, with the hillshade showing through. So you're getting an idea of the elevation, this being higher, this being in the middle, the lower elevation, you get the idea. So the higher is the white, here's the lower down here in the blue, and you're getting an idea of the shadows. Now some people put the hillshade on top and make that transparent and the DEM below. It's a matter of personal preference. Now what I'm going to do is to show you the information about the aerial photography or the imagery that is associated with this area. Now what you need to do is to go to the tab, and at the drop down select GIS servers and select the MinGeo website, all right, to pick up their WMS server. Now if you don't have that information, you could go to the MinGeo website and find that information in their web services, WMS services, and you'll get and at the geospatial image services, you could get the technical specs, and you could copy that URL. Now once you've copied that URL, you can do an add WMS server and add that. Now I've already added this aerial imagery, so I'm going to add that. Now the aerial imagery is displayed, and using the effects cursor toolbar, I'm going to select that aerial imagery, and then I'm going to use the pan to examine that so that I could see this is where the house is in this location. Here's where the wetland, here's where a drainage conveyance is. You get an idea of how you can swipe it, and you could swipe it sideways or up and down. And this is very, very useful to examine what the imagery shows, as well as your hillshade and DEM. Okay, now we're going to turn the DEM off, and we're going to put the aerial imagery below the hillshade layer, and we're going to establish the hillshade layer as transparent to see the imagery through it. How we do that is in Properties on the hillshade layer, in Display, and I'm going to display that at 60%. Apply, OK. And if I zoom to the hillshade here, you can see that that imagery is being displayed through the hillshade. And you get an idea, a better idea of the landscape when we're seeing the shadows over the top of our aerial imagery. Okay, now we're going to turn off our imagery, and we're going to, for our hillshade, turn that back on to no transparency. Now we're going to go back to our DEM, and we're going to change the DEM display to be what Sean calls fire, a specific way of displaying the DEM to better reveal the hydrological features. Now to do that, we have to get into Properties, and we're first working with the Display option, and our transparency here we're going to set at 40, and we're going to set our brightness at -30. Now remember, that's -30, all right? And our contrast we're going to set at 70. Okay, now this is a little different than you're used to. Okay, I'm going to apply that, and then my symbology, I'm going to want to use stretched, and I'm going to want to use a special color ramp, which is the 5th from the bottom of the list here. So 1, 2, 3, 4, 5. Okay, yellow to dark red. And my standard deviations is 2, and I'm still using from current display extent. Now, if I want to check to make sure I've got the right color ramp, I can right-click, point it here, and right-click, and I can go to Properties for that. Excuse me, I said Properties, to save style, and you'll see the default name that comes up. It's yellow to dark red. So you know you've got the right color ramp. Then you're going to apply, OK. And this is what Sean Vaughn refers to as the fire. And the reason he refers to that is because the color ramp puts the darkest colors into the lowest feature. And so it really helps to identify the hydrological features of the landscape. So the idea is the bottoms of the watercourses are black, and so that you would be able to better, when you zoom in, you'd be better able to see the what you need to digitize. This now ends the, I'll zoom to layer here, this now ends the DEM display first lab exercise video.